I had just started on the team. This was about maybe 6 months to a year in. The science office, they said, you know what? We need to send the engineers to the Mojave Desert. There was one, I think this was towards the tail end of the trip. They took us to a site, they gave us a map, and they said, okay, you are now the rover. And this is the only information that you have. These are just images, aerial images of the area nearby. Go tell us where you would find evidence of life. It kind of made me think like one day we could be walking on the surface of Mars and maybe doing the same exercise. So that was kind of cool.
This is NASA's Curious Universe. I'm Patty Boyd, and in this podcast, NASA is your tour guide.
My name is Cristina Hernandez, and I'm a payload systems engineer at NASA's Jet Propulsion Laboratory in Pasadena, California.
Cristina is one of the engineers that helped build the Mars Perseverance rover, which will soon allow us to explore Mars in a way we've never been able to before. Ever wonder if there's life beyond our home planet? Some key answers might be locked up a little further into the solar system, on Mars. And over the past few years, NASA's been building a rover that might just hold the key.
When I started, we were still at a paper design, and we were just focused on trying to understand if it was the right design and how we were actually going to build this beast of a rover. And now, right, in the recent years, we've transitioned to what I love the most about engineering now is, building hardware, testing hardware, and eventually building the flight rover and flight instruments.
It's taken 10 years to get the Mars Perseverance rover ready for launch day. This summer, the rover will embark on a hunt for signs of ancient life on Mars. The historic mission will be the first step in a round-trip mission to Mars. It will collect rock samples for future return to Earth. The Apollo lunar samples, collected by astronauts decades ago, are still allowing us to make discoveries about the moon. There's no telling what samples from the red planet could teach us. And that's why these samples are at the core of the mission's 4 key goals.
So the first goal is, did life ever exist on Mars, right? Is there evidence of past life? And we have so many great science instruments that are going to help us answer those questions.
The second goal is to learn more about the climate on Mars.
What's Mars climate like, right?
We want to know how it became what it is today.
And at the same time, learning about Mars climate could also help us understand our own Earth climate, which is, always important.
The third goal is to understand the geology of Mars, the sort of thing that Cristina was learning about on that trip she took to the Mojave Desert. And then there's the last goal,
which is the goal that, as a little kid, this is the one I always dreamt of, is we are finally preparing for human exploration on Mars, right? It's an actual goal, right? It's always been a vision, it's always been a dream, but on this rover, it is one of our 4 science goals. And so that's why we're going to Mars, and that's why folks like me are so excited for this mission, because this is cutting edge stuff.
But Perseverance still has a ways to go before it starts on these goals. In late July, the mission's launch window opens. After leaving from the Kennedy Space Center, it will take the rover 7 months to travel to Mars. That means it'll get there in February 2021, at which point it will have to complete one of the most difficult parts of the entire mission.
We're talking about entry, descent, and landing, or EDL, the EDL process.
It's known as the 7 minutes of terror. For that period of time, NASA will not be able to communicate with the rover, and the computer will have to move the mission through a perfectly choreographed set of motions without any help from the ground. Mitch Schulte, the Mars Exploration Program scientist at NASA headquarters will walk us through what the EDL process will look like for Perseverance.
The entry part is when the rover first hits the top of the atmosphere of Mars. The heat shield then starts to interact with the atmosphere, creating a lot of friction. This creates a lot of heat, but it also takes some of the energy out of the spacecraft as it's coming into Mars. The heat shield eventually drops off after we've gotten through enough of the atmosphere and slowed it down enough. At that point, we have a parachute that deploys out of the back shell that opens up at hypersonic speed, so it's going faster than the speed of sound, and we have a very large parachute then that helps us slow it down even further. And then by the time that the parachute slows us down enough, the rover will drop out of the back shell that's carrying the parachute, so we'll be free of the parachute. At that point, what will happen is that there's a radar on board the rover that will detect where the ground is and fire the retro rockets that will finally allow us to get the rest of the way down to the surface of Mars. So we're going to a place on Mars called Jezero Crater, Jezero. This is actually a crater that was once filled with a lake, and it's in a really ancient part of Mars, about 3.5 billion years old. This area of Jezero Crater, which is now dry, there's no liquid water in it now, but there's evidence in the rock record that there was a liquid water lake there 3.5 billion years ago. And everywhere we go here on Earth where we have liquid water, we find life. We in the Mars Exploration Program like to point out that we've been sending things to Mars for quite some time, and we'll be happy when the humans finally get there, but we've got an entire planet inhabited by robots at the moment. What we're really trying to establish on Mars is whether there was life there in its ancient past. So now that we've established that there was liquid water early in Mars's history, we think that it could have been habitable, like Earth was and is now. So we really want to get after this idea of establishing what kinds of places on Mars were habitable and whether life actually did get a start on Mars. And so what we're doing in sending all of this technology and these technology demonstrations and this hardware to Mars is really helping us move forward in the technologies that will enable humans to visit Mars.
Now you might be wondering, what will Perseverance look like as it's roving around Mars? And what will it be doing? Well, it looks very similar to Curiosity.
Because it's the same design, and the reason that we use the same design is, one, we know it works really well on Curiosity.
Imagine a car-sized robot with extra limbs and a camera for a head.
We have upgraded the wheels. It turns out the rover actually is pretty heavy.
Perseverance clocks in at 2,260 pounds.
So that's been putting some strain on the wheels. We've corrected that, redesigned the wheels, and so the wheels are going to be much better this time around.
One of the great things that we do have is data to try and understand the different types of terrain and also the slopes that the rover could see. The Perseverance is equipped to kind of handle different types of terrain because of the wheels. And we even have requirements to say, look, we need to be able to travel up slopes that are, 20 degrees high, right? Because we need to be able to just be prepared for if there is something interesting that's really going to drive us over there, we have to be ready.
Christina likes to think of the different pieces of Perseverance as they relate to the human body.
So for example, within the rover, right, within that kind of that big box, all the vital organs, all like the sensitive electronics that kind of give life to the rover, that's where that's kept. When you think about, the rover, right, the rover's kind of like a robotic scientist, right? We try and pack as much as we can of what a geologist would do, what tools they would bring, and put that on the rover. We've got the brains, which is obviously the electronics and the software that control everything. We also have the neck and the head, which on the rover, we call that the mast, the remote sensing mast. And the remote sensing mast on Perseverance has all these really neat cameras that are going to help the rover see. And ears, we have a microphone provided by the SuperCam team on the rover, which is like a first and really cool. And, you know, obviously the wheels, right? We got to rove around and go check things out.
And as Perseverance is doing all of this, it's got to keep us in the loop.
And the way we talk to Earth is through our antennas. And so that's what we use to speak to Earth and also allow Earth to say hi back and check in on us. So that's kind of like the overview of the rover.
It's always exciting to get messages from the rovers through those antennas, receiving pictures and data as it explores the red planet. But this time, we're hoping to get something else. We've successfully landed 8 robots on Mars before, 2 of which are still working. And each of them have helped us understand the planet a bit better. But Perseverance is taking us a step further.
Unlike other missions that have brought samples back from celestial objects before, like comets and asteroids, this time we're bringing samples back from a planetary body, Mars, that may have had life on it.
We're trying to bring pieces of another planetary body all the way back to Earth. And we're hoping that those pieces, the samples, might help us answer a question. Did life ever exist on Mars?
We want to make sure that we do the best job in collecting these samples, and we're going to be doing it from 150 million miles away.
It's kind of like when Christina and the other engineers went to the Mojave Desert and were told to look for rocks that might show signs of life. But instead of a short drive across California, we're talking about a 7-month journey through space. And instead of our own 2 hands, we've got a car-sized, semi-autonomous robot doing the job.
So they've built in a lot of technology that will enable careful handling of the samples and make sure that we get the best possible samples that we can get.
And when you bring a sample back to Earth, you can give that sample to institutions across the world, have them use their labs, have them study it for decades to come, right? And it's huge, right? We've never done this before, and it just...
While sample collection is one of the most exciting parts of the rover's mission, Perseverance will be quite the multitasker. One of the instruments will test out how we might convert carbon dioxide to oxygen. This could fuel future rockets to get them back to Earth, in the event that, we get humans there and they want to come home. Another instrument will monitor the weather on Mars, keeping track of temperature, humidity, and dust size. Each of Perseverance's instruments will help us achieve the mission's main science goals. This will also be the first rover to bring along a companion.
We are going to send, and I gotta you gotta really process this. We are going to send a helicopter with the rover, right? So for the first time outside of Earth's atmosphere, we are going to be flying on another planet, right? And so Ingenuity, which is our Mars helicopter's name, is gonna take flight once we land on Mars. And that is pretty amazing that, some crazy team at JPL, right, put together this helicopter and we're like, yeah, let's bring it along. Let's go and figure out if we can fly on another planet, because that is going to even increase our capabilities even more. And so
we've built a little house for the helicopter on the underside of the rover. And so after the rover lands, it's going to get lowered down to the ground. It's folded up inside this house. It's going to get lowered down to the ground on cables. The cables are going to get detached from the rover. The rover will drive away, and then the helicopter will unfold itself and be ready to fly.
Ingenuity will be able to give us an aerial perspective of Mars, making observations that could tell us how we might use the planet's resources one day.
We have lots of cameras on Perseverance, so we'll be able to take all kinds of great pictures and probably some video of the helicopter doing its thing. We'll also have a video camera on the helicopter itself, so it will be taking video as it's flying.
Imagine this. In the future, when humans are on Mars, they may call on helicopters like Ingenuity to scout out new locations and investigate cliffs, caves, and deep craters. The helicopters could even carry small payloads of supplies. But before any of that happens, a test vehicle has to prove that flying on Mars is even possible. And that's what Ingenuity is going to do.
So at the moment, we have 5 demonstration flights planned, each one a little bit longer than the last one. And so we're going to first make sure that it actually lifts up off the ground and can actually fly. And then we'll test and see how long we can do that. And then if we get creative, we can start to maybe maneuver it around a little bit.
Mars Perseverance is a pioneer, a robotic scientist that will travel to Mars and attempt to learn its secrets. The rover will launch from NASA's Kennedy Space Center soon. The launch window is set from July 30th to August 15th, but no matter when it launches from Earth, if all goes as planned, roughly 7 months from now, on February 18th, 2021, we'll get some photos back from Perseverance as it takes its first look at this foreign landscape. And it'll be clear, we're not in the Mojave Desert anymore.
I keep kind of thinking about the launch, and I know I'm gonna cry, I know I'm gonna laugh and jump and just be super excited, because this project has really meant everything. Like, everybody on this team has given it their all, and we've all made the sacrifice of not being home on holidays, weekends. You give it your all because we know it's going to be such a rewarding thing to see this thing launched. Perseverance means everything, and this was my first flight project, right? I've never sent anything outside of Earth before. I couldn't have picked a better name for this personal and this team milestone. I mean, to me, perseverance means grit and passion. When we say, do you have the right stuff? To me, part of it is perseverance. It's understanding the sacrifices, understanding that everyone's in the same boat, being empathetic to your team members when they're having rough days, and building this robotic vehicle that's gonna go and collect samples and do cutting edge science. And yeah, let's throw a helicopter in while we're at it. This mission, this name, it manifests the last 5 years of my life, in all aspects. This is what engineering is, and this is what science is, and I couldn't have done this anywhere else. That's what it means.
This is NASA's Curious Universe. The Curious Universe team includes Klaus Meyer, Michaela Sosby, and Vicki Woodburn. Our executive producer is Katie Atkinson. Special thanks to Ryland Heggie, Joby Harris, Jim Green, Andrew Good, and Liz Landau. If you liked this episode, please let us know by leaving us a review, tweeting about the show at NASA, and sharing us with a friend.
This is really what you get into science for. It's for moments like this. You're ready, your team is ready, and these things happen at random moments. And so you have to be ready when opportunity knocks.
Everything we've seen has been surprising. Just the sheer amount of structure in the solar wind. The fact that when we first saw the magnetic field data, the first worry was, oh no, is the instrument malfunctioning?
Hello, Houston. We are inspired. We are ready. Let's go fix this thing.
Sounds like a good plan, Endeavor. Good morning.
It's changed everything we know about the universe, the planets in our solar system, the way that stars are born, live, die, the most distant galaxies. This is one of the grand adventures of NASA.
sometimes the blanket person, we might be the last ones to touch the spacecraft before it launches.
It's a real sense of awe, I think, that we find in the natural world, and there are many different places you can find it.
You know, being out there on your own in a spacesuit, looking back at the planet, you're really in this self-contained life support system, really your own little spaceship.
Welcome to NASA's Curious Universe. Our universe is a wild and wonderful place. And in this podcast, NASA is your tour guide. Subscribe right now and get ready for a grand adventure.
One of my favorite places on Earth is one of the most beautiful parts of the Amazon basin that I've ever had the privilege of visiting. There's a national forest right next to the Tapajós River, and it's a place we've long studied in the central Brazilian Amazon. Inside the national forest, we've built a tower that allows you to walk up 150 feet into the air. As you walk the steps of this metal tower, you finally step out into the sunlight on the top of the canopy. You're surrounded by an ocean of green. And in every direction you look, you're seeing the vivid colors of the tropical rainforest canopy. It's really striking to me to be able to feel so immersed in that environment, from the forest floor all the way to the canopy. And if you're sitting there at sunset, when the macaws are coming into roost, the monkeys are making their last calls for friends or food, it's a really peaceful and alive place. It just reminds us that there are fascinating things yet to discover on our planet.
Welcome to NASA's Curious Universe. Our universe is a wild and wonderful place. And in this podcast, NASA is your tour guide.
I'm a research scientist,
earth scientist, project scientist
at NASA.
When you think of NASA, you might think of all the incredible mysteries of outer space. We're also pretty invested in another very special place. I'm Patty Boyd, and in this episode, join me on an exploration of one of the most fascinating places in the solar system, Earth. This April is the 50th anniversary of Earth Day, and we're explaining some of the ways NASA keeps an eye on our home planet.
Sometimes here at NASA, we like to say that every day is Earth Day.
That's Doug Morton. He's one of the many Earth scientists at NASA.
Studying our home planet has always been a really important part of NASA's mission. NASA has so many different ways to study our planet, and as a scientist, it's my job to think about which of those different measurements are important for the questions I'd like to look at.
Think of all the amazing parts of our planet. Earth is home to volcanoes, deep oceans, sprawling deserts, and growing cities. It's the only planet we know of that can sustain life. That's a lot to keep track of, and everything is connected. NASA's Earth scientists work to monitor and measure these systems so we can better understand how our home planet functions and how it's changing.
NASA's satellite data records really tell the story of our changing planet. In the last 30 years, we've watched the polar ice caps shrink. We've actually been able to estimate the amount of water that's been lost from glaciers and ice sheets by weighing water from space. We've been able to track changes in forests from natural disturbances like hurricanes or wildfires, or the expansion of agriculture that shifted production of grains and crops from places like the Midwest in the United States to the frontier of the Amazon basin. We've been able to track changes in our atmosphere that relate to how volcanoes put sulfate particles high into the stratosphere, or how the ozone hole has actually been shrinking over the time record of our satellite data. Each of these scientific discoveries really depends on having a knowledge of our home planet, as well as the information and the regular, carefully calibrated and collected measurements we take from space to track those changes over time.
Those carefully calibrated measurements can help scientists like Doug gather information about our planet and predict patterns for the future.
From space, NASA has a really unique role to play in terms of how we understand our home planet. Our scientists have designed instruments to be able to take measurements of our atmosphere, our oceans, ice cover, and vegetation. And as we put those pieces of the puzzle together, we're able to look at our entire Earth as a system, and all of its complexity.
NASA has a global view of living ecosystems, both on land and in the sea, something made possible by satellites. With that view, we can see the effects of our changing planet on the life cycles of things like forests and plants. We can even track wildfire outbreaks in remote areas, sometimes before first responders on the ground. NASA Earth scientists study all sorts of things.
One of my areas of research is how wildfires are changing our planet. Really, someplace on Earth is always on fire, and our NASA satellites are often the first to detect those fires and, of course, to track their changes. What do those fires mean for people living in communities close to the fire? Where does the smoke from those fires go? And how might it impact people living in cities far away, as well as the greenhouse gases that build up in our atmosphere?
We can understand a lot about Earth from space. We can use scientific instruments to help us learn about things like air pollution. Anne-Marie Eldering, a scientist at NASA's Jet Propulsion Laboratory in Pasadena, California, works on one of those tools.
A lot of folks know about the NASA work focused on solar system and Mars and planets, and they don't realize how much we're doing about our home planet. The International Space Station has been flying around our Earth for quite some time, but people maybe don't know too much about what's going on up there. I'm the project scientist on the Orbiting Carbon Observatory 3. That's an instrument that's installed on the International Space Station to measure carbon dioxide around the globe.
Before she came to NASA to work as an Earth scientist, Anne-Marie wanted to be an engineer.
It's only when I came out to Los Angeles and saw the beautiful smog that was here in the 1980s did I realize, you know what, air pollution is my calling. It felt exciting because it was a tangible problem I could see, and the questions we were going to answer were actually going to make an impact. There's sort of 2 or 3 things that are most critical to the work that we do, and one of those is the measurements from our instrument, from OCO3. What we look at is we see that sunlight is gone through the Earth's atmosphere, reflected off of the Earth's surface, and then comes back to our instrument. And so we measure this amount of light, and every molecule in the world interacts with light in a very unique way. So if you measure the light really carefully, you can learn about how much carbon dioxide was in the atmosphere.
With this technology, scientists can get a deeper look at complex gas mixtures and particles that could be harmful to human health. They can figure out the sources of dangerous air quality and how to improve it. Scientists aren't just interested in surveilling the planet, they want to be able to use the information gathered to look towards the future.
When we think about our Earth and the climate of Earth, we see signs that the climate is changing, but one of the things that's been difficult to do is really predict well what it will be like in 2040 or 2050. So in my mind, when we're thinking about the kids today and what the world's going to be like for them, we want to have some more information to understand that better. And the data we collect is going to help us understand how carbon dioxide flows through the plants and the ocean and the atmosphere. And when we understand more about how it's moving around, we'll be able to tell you more precisely what 2050 might be like.
Understanding Earth gives us the means to better protect it. NASA scientists travel to some of the most dynamic places on our planet to bring back information that helps us understand Earth. And in turn, that information helps us understand our whole universe.
Some of the measurements we can make from space are incredibly valuable, but many other measurements have to be taken on the ground. NASA scientists today are actually spread all over the world. We have a team of people out studying snow in the high mountains in Colorado. We're about to send off a team to the mud flats on the south side of the Everglades National Park to understand how mangroves that were damaged by Hurricane Irma have recovered in the last 2 years. We're sending teams of people to Africa to understand how dust that blows from Africa makes its way all the way around the globe and fertilizes places as far away as the Amazon. My first trip into the Amazon, I remember sort of being overwhelmed, not just by the kind of emotion of arriving finally at the forest frontier, but also kind of the activity. As you step into the forest you're struck by the fact that the forest environment it's cooler, it's more humid, and it's alive with sounds. You get the chorus and calls of birds and primates, frogs, and other species that just remind you that you're stepping into a world that has thousands and thousands of species, many of which we've not even discovered or described. It's a real sense of awe, I think, that we find in the natural world, and there are many different places you can find it. And so we're in the field with our colleagues making measurements of trees, mangrove roots, of soils and their changes, and listening for sounds, because sounds are another kind of remote sensing that we can make in the location that tells us something unique and different from what we can learn from space. NASA scientists are working really across the globe, and we're using a number of different tools to study our planet and how it's changing.
At NASA, there are actually entire divisions and missions completely dedicated to Earth science. From wildfires to sea level rise, there's a lot to keep an eye on. The data that NASA collects makes a record of our home.
One of the exciting things of working here at NASA is that we have a long record of satellite observations, and that actually allows us to go back in time. So when we think about the ways in which we're studying our planet and its changes, my first thought is we can begin in the 70s or the 80s and start to step forward in time until the present. And that's a really powerful way to look at our planet. And one of the things I think that's a really important foundation for a lot of the work we do going forward is that we do have this long time series of measurements, ice cover, of vegetation, of land use and agriculture, changes in oceans and atmospheric properties. And that long time series really is the basis on which we're understanding the subtle but important changes in our planet.
Before satellites, we knew virtually nothing about the huge ice caps of Earth. Now they've been mapped in incredible detail over several decades. We know more about why Arctic sea ice is shrinking and the loss of water from the Antarctic and Greenland ice sheets. Both of these things are major causes for sea level rise, and we've learned that based on a long record of data.
Over the years, as we've learned to better understand our home planet and to create the kinds of instruments and imaging tools that allow us to take pictures from space of our home planet every day, often more than once per day, we've built really important connections with the farming community, with wildfire and disaster response communities, and a number of other applications that really depend on having information in near real time to respond to ongoing changes. Whether you're a farmer trying to understand whether you need to irrigate or fertilize your field, or you're a firefighter trying to figure out where the next blaze started and how you're going to respond to protect a community in the hills of California. That's where the information that comes in from our satellites today is so valuable for making decisions today. And of course, every day of observations continues our long data record of observations that helps put today's changes in the context of the past.
Doug and Anne-Marie are just two of the many Earth scientists who study our planet each day and monitor its changes.
It's hard not to be overwhelmed by the magnitude of many of the recent changes. Someone who studies wildfire, we're right in the mix of that emotional swirl of wanting to help people in need, of wanting to understand the changes, and as well unable to ignore the consequences of fires, whether they're happening in Australia, the Amazon, or Alaska. Every year from space, we map more than 1 million large wildfires. Every one of those wildfires is important to a community. It doesn't have to be the world's biggest, fastest, hottest, or most extreme fire to be important. I think that's something we always try to keep in perspective. But there are days when it's difficult. It's a lot to manage. The emotions of the fact that those 1 million wildfires are doing damages to communities, are changing air quality for people near and far, and are part of the way in which our planet is responding to warming and drying conditions.
You know, by nature, I'm actually a fairly optimistic person. I always somehow manage to find a way to think, well, there's an opportunity for change, an opportunity to advance, and that's the road we're going to take. Certainly when you study things like climate and air pollution, you can see the change over time, and there's some things that we see improving and there's some things that aren't really improving. But I feel like people are engaged in these questions. They're thinking about the choices they make and the impact it has. So I remain optimistic that people want to learn, they want to understand, and they want to make a good decision in the big picture.
And I think it's important to remember that there are scientists at NASA and really across the world whose primary goal is to keep tabs on what's happening on Earth every day. I think that's reassuring. It's exciting to have a momentous occasion like the 50th celebration of Earth Day. I think to really look back at how much we've learned over those 50 years and how much we have yet to do in terms of our collective action in safeguarding our home planet. It's really exciting to think about what we'll learn and do over the next 10, 20, or 50 years. In a way, it's almost impossible to imagine, and I think that's the exciting part about working at a place like NASA, where we're always thinking about the future and where the possibilities seem pretty endless.
Earth is a truly incredible place, and seeing our planet from space gave us a new appreciation of it. In 1968, astronauts on board Apollo 8 were orbiting our moon when they spotted something incredible on the horizon.
Oh my God, look at that picture over there.
A bright blue marble rising over the dusty lunar surface.
There's the Earth coming up. Wow, that's pretty.
That voice? It's astronaut Bill Anders.
Is that a color film, Jim?
He doesn't know it yet, but he's about to take one of the most iconic photos of all time.
Give me a roll of color quick. Oh man, that's great. Where is it? Quick.
Earthrise. A reminder that we're all in this together. On this Earth Day, it's important to remember how special our planet really is. After all, we only have one.
It's amazing when you stop and think about it, the variety of life forms that exist and the temperatures that are perfect for us and the way the atmosphere protects us from the UV radiation. I mean, it's really actually pretty astounding that the Earth creates this habitat where we and all the life forms of the Earth can exist. What a wonder.
This is NASA's Curious Universe. The Curious Universe team includes Elizabeth Tammy and Michaela Sosby. Our executive producer is Katie Atkinson. Special thanks to Leslie Mullen, Colin McNutt, Michael Pallas, and Danielle Rappaport. If you like this Curious Universe episode, please let us know by leaving a review or tweeting about the show at NASA. Take a deeper dive by checking out the show notes. Join us next week as we explore a historic NASA mission, the Hubble Space Telescope, our window to the stars. We all know what it's like to wander outside and look up at the night sky. On a clear night, when you can see all of the stars perfectly, it's so easy to feel small. It makes you wonder, what's out there, beyond what we can see? The Hubble Space Telescope has helped us answer that question over the last 30 years, revealing that reality is often stranger than fiction. We've seen the births and deaths of stars, and we've found answers to questions we'd never even thought to ask before. We've learned all of this in incredible detail by looking back in time.
Hubble is like a time machine in the sense that we can look farther and farther out into the universe at these fainter and fainter, more distant galaxies. And by doing that, we're really looking back in time because it has taken time for that light to get to us from these stars and galaxies.
That's Jennifer Wiseman. She's the senior project scientist for Hubble and says that the telescope is achieving more than scientists originally expected.
Hubble has recently contributed to the determination that the expansion of the universe is, in fact, accelerating. That was unexpected. Hubble has become the pioneering telescope in analyzing the atmospheres of exoplanets. Hubble has found the likely presence of water in moons around other planets using interesting, innovative techniques. That was really not something Hubble was originally designed for. So we're using Hubble now for kinds of science we did not originally anticipate.
And after all this time, the discoveries we get from Hubble every day are still knocking us back, telling us more about the nature of our universe and its origins. But Hubble's journey to the stars was a difficult one. So how did it succeed? Welcome to NASA's Curious Universe. I'm Patty Boyd, and in this episode, we're exploring a truly iconic NASA mission, the Hubble Space Telescope, our window to the stars. This is the story of how NASA put a telescope in space. Decades before the Hubble Space Telescope was even a possibility, the idea of looking beyond our own atmosphere was at the forefront of astronomy. Back then, most astronomers believed that the universe consisted of just one galaxy, our own Milky Way. Then, Edwin Hubble came along and changed everything. From a mountaintop near Los Angeles, he peered up at the night sky with a ground-based telescope, the Hooker telescope, which at the time was the largest one in the world. That's when he spotted something amazing. The fuzzy objects he noticed in our sky were actually other galaxies. And most of these galaxies he spotted looked like they were moving away from each other.
Edwin Hubble was one of the pioneers that determined that our universe is in fact expanding. Galaxies seem to be moving apart from each other along with that stretching of space, but we couldn't quite discern the rate of that expansion. It's a very difficult measurement. So the Hubble Space Telescope was able to contribute to a really higher precision measurement of that expansion rate by measuring more carefully the distances of these galaxies and correlating that with other measurements of their apparent velocities and giving us an expansion rate that was much more refined than anything ever before.
Edwin's discoveries made scientists wonder. If we could see all that coming from a ground-based telescope, what would happen if we sent one above our murky atmosphere? German scientist Hermann Oberth dreamed of what we might learn.
If we could look at the heavens with an astronomical telescope in orbit, unhindered by the shielding sea of atmosphere that blankets the Earth, think of the discoveries we would make, the clear vision of the universe we would have.
Echoing Oberth's vision, astronomer Lyman Spitzer outlined the details for how to make it all work in an academic paper that would really set the stage for Hubble. NASA set out on an adventure to place a telescope in space. This telescope would discover things that would revolutionize the way we think of our place in space. Here's what the great astronomer Carl Sagan had to say about this bold experiment.
Space telescope is, in a way, a little like Galileo's first telescope. Wherever Galileo pointed his telescope, he made major new discoveries. Look at the moon, you find mountains and craters. Look at Saturn, you find rings. Look at the Milky Way, you find it is littered and oozed of stars. Every one of these discoveries, things that people had not known before. I think it's going to be very similar with the space telescope. It will illuminate celestial objects that we know about. It will discover celestial objects never before guessed. It will provide insights into the most important questions, such as stellar evolution, such as the search for planets going around other stars, and the grandest cosmological questions of the origin, nature, and fate of the universe. Space telescope is a kind of grand intellectual adventure for all of us, which will cast light not just on the cosmos, but also on ourselves.
The telescope was built at Lockheed Martin in California, with NASA's Marshall Space Flight Center overseeing the telescope's construction. It was named after Edwin Hubble, who paved the way for grand discovery. But actually getting a telescope the size of a school bus into space is difficult, as you might imagine. That's where the Space Shuttle Discovery comes in. NASA's space shuttles were designed to carry and deploy spacecraft like Hubble. With the Space Shuttle Discovery, NASA astronauts would deploy Hubble at the edge of space in low Earth orbit and return safely to Earth. NASA designed the telescope to fit snugly inside Shuttle Discovery, which carried and released this precious cargo into space.
The Shuttle Discovery, poised at Cape Canaveral for a launch tomorrow morning. It may be the most ambitious and eagerly awaited mission in the history of the shuttle program. On board a giant telescope that will redefine our view of the universe.
When it launched in 1990, NASA's Hubble Space Telescope was only designed to last 15 years. In 2020, the telescope celebrates its 30th birthday, and Hubble is still as powerful as ever.
Hubble makes discoveries 24 hours a day. It's up there orbiting the Earth, and it goes around the Earth about once every 90 minutes. And so,
That's Michelle Thaler, an astronomer and science communicator at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Goddard is home to Hubble's mission control.
The Hubble Space Telescope is something that just changed everything. I think people now have this view, what does space look like? And they don't even realize that what they're thinking of is something that Hubble images brought to our culture, to our imagination.
She's right. When you close your eyes and imagine space, you probably picture stars, beautiful colors, and a sheer vastness. The images that pop into your head are probably star-studded and full of the colorful clouds of nebulas. That's because the pictures taken by the Hubble Space Telescope are the clearest and closest we've ever come to looking at our universe. They've fundamentally shaped how we think of space. And from space, Hubble can see a lot. Here's one way of looking at it. Imagine going to a piano concert, and the musician sits down and can only play 3 notes around middle C. That's the amount of light we can see here on Earth. Then there's a whole spectrum of light our eyes aren't sensitive to. And that's where Hubble comes in. Hubble can see in multiple wavelengths of light, like infrared and ultraviolet. So Hubble's view would sound a lot more like a symphony. NASA made a huge push in the years leading up to Hubble's launch to promote the revolutionary telescope's efforts. NASA promised the public that this project would lead to important discoveries and answers. After all, this was the culmination of decades of work and research, not to mention the financial and emotional investments riding on this mission. On April 24th, 1990, the telescope launched.
3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Back on Earth, Mission Control monitored the deployment carefully. They knew what was at stake.
And this is Hubble Telescope Control in Greenbelt. We have been given the go-ahead to begin commanding release of the forward latches, which hold the solar arrays in place during launch.
When the Discovery crew set out to deploy the telescope, they were under a lot of pressure. After all, Hubble was set to be the greatest astronomical advancement since Galileo picked up a telescope. But something went wrong.
Of course, when Hubble finally got up and everybody was really excited, there was this amazing sense of deflation when they opened up the telescope, light went through it, and they realized the images were out of focus. And they were out of focus because the curvature of the mirror was wrong. So, this was just an incredible mistake. People have been making very accurate telescope mirrors for a long time. And the fact that all of a sudden, up in space, what were we going to do now? This incredibly valuable instrument was launched, and there was this tremendous problem.
The first pictures that NASA saw here on Earth were fuzzy and distorted. And it was all because of an incredibly small, almost undetectable aberration. A tiny error from when the mirror was constructed. Hubble's vision was blurry. But the telescope was still technically doing its job, at least as far as astronomers like Michelle were concerned.
The spectrographs still worked just fine. The images were out of focus, but all of the data, the really detailed data about the universe was still coming in through these spectroscopic instruments. So for people specifically doing my science, Hubble started working beautifully. We were making incredible discoveries. But of course we wanted to get those clear images, to see the universe without the distortions of the atmosphere, to see it beautifully, beautifully clear.
From the beginning, Hubble was designed to work hand in hand with the Space Shuttle program. NASA had anticipated that Hubble would need to be modified and expected to send astronauts to do so in the coming years.
What was not anticipated was that the first images coming from the Hubble Space Telescope were quite disappointing. There was obviously a problem.
Telescope system optics. The conclusion we've come to from that is that there's a significant spherical aberration appears to be present in the optics, in the optical telescope.
The mirror on Hubble had been ground beautifully, but to a slightly incorrect formula, and this had not been caught in testing.
This incredible idea was raised, why don't we fix it? And then this is one of the grand adventures of NASA.
NASA set out on a daring rescue mission to save the Hubble Space Telescope.
They came up with a very insightful solution. Basically, in some sense, it's been described as putting glasses on Hubble.
These glasses were actually an instrument which was designed to correct Hubble's flaw. A team of astronauts were prepared to service the telescope in space.
Hello, Houston. We are inspired. We are ready. Let's go fix this thing.
Sounds like a good plan, Endeavor. Good morning.
They made an instrument that actually corrected the light before it went into the cameras, took out the wrong curvature.
Okay, I'm in 1 inch. You're in 1 inch, and I have it. You have it? Yes, I have it. Okay, I'm going to let go.
All of a sudden, things snapped into just beautiful, beautiful focus. Everything was gorgeous. So it is one of the most amazing happy endings in the history of science and the history of technology.
Hubble's servicing missions didn't stop with its initial rescue. Over the years, Hubble has been serviced multiple times. John Grunsfeld is one of the astronauts who helped keep Hubble in top shape.
For me as an astronomer, going out in a spacesuit and working on the Hubble is just the ultimate experience. There's nothing cooler. The Hubble is an incredible icon of science, and so to me it was the holy grail of being an astronaut.
John worked on 3 repair missions to the telescope, earning the nickname Hubble's Keeper from publications like the New York Times.
I was expecting, the wonders of space and the beauty of the Earth. What surprised me the most was that I kind of discovered my humanity. That being in a tight crew, working together as a team with hundreds, thousands of folks on the ground, that there's really nothing, I think, that humans can't achieve if we work together as a team, and if we have good challenges, things that are worth doing, we can do almost anything.
We know so much about our universe now because of people like John. People who were watchful stewards of the telescope and who dedicated themselves to its success.
Hubble has lasted a lot longer than we expected. We thought Hubble might last 10 or 15 years if we were lucky, but thanks to the series of astronaut servicing missions over the years, the telescope has been refreshed over and over again with repaired instruments and new batteries and gyroscopes and things like that, refreshed new instruments as well. And that has made the telescope basically brand new, more or less, every time we've done a servicing mission, and that's kept it at the forefront of scientific discovery.
To get a look at the outstanding imagery from the Hubble Space Telescope, visit nasa.gov/Hubble. You can also follow the telescope on social media at NASA Hubble. This is NASA's Curious Universe. The Curious Universe team includes Elizabeth Tammy and Michaela Sosby. Our executive producer is Katie Atkinson. Special thanks to the Hubble Space Telescope team. If you're enjoying Curious Universe, consider leaving a review on your podcast app or tweeting about the show at NASA. And in the next episode, astronaut Nick Hague takes us to an underwater training ground.
The Neutral Buoyancy Lab, or the pool as I like to call it, it's a really remarkable place. It's so massive, 200 feet long, 100 feet wide, and the water is crystal clear. And if none of the safety divers have started to get in the water yet, the top is as still as it can be. The water's so clear you can just see straight through and see all the models down in the water. And so you get to see the magnitude of what you're going to go down and work on here shortly. It's an amazing experience. When I first came down here, that was when I first put on the spacesuit and was lowered into the water and started floating around in the water. It felt like this is astronaut training. Hi, I'm Nick Hague. I'm an astronaut at NASA. I explore space for a living.
This is NASA's Curious Universe. Our universe is a wild and wonderful place. I'm Patty Boyd, and in this podcast, NASA is your tour guide. In this episode, we're exploring the underwater training ground where astronauts train for space. There are humans in space right now. In fact, humans have lived in space continuously for nearly 20 years on board the International Space Station.
This International Space Station, it is gigantic. Imagine this space station floating around with these gigantic solar arrays, these wings of solar cells that are collecting the sun's energy, and that's how we power the station. It's the size of a football stadium. On the inside, it's got kind of the volume of a large jumbo jet, and so that's the area we live and work in. We're up there, it took 100 launches and it took 100 spacewalks to put this thing together, and we've been up there living inside the station. It's been inhabited continually for 2 decades now.
The space station orbits around Earth, about 250 miles above ground. The international crew that lives and works on board is doing critical research that can't be done anywhere else.
We're up there trying to perform this science because on the space station, gravity isn't the dominant force. If you look around you, everything around you is controlled by gravity. Everything in the room you're sitting in is held down to a table or to a floor because of gravity. And up there, all that goes away. And that's when we can make some really key scientific discoveries.
The ISS is a unique place to study human health and medicine, on top of the more obvious scientific questions about astronomy and meteorology. Weightlessness helps us understand the possibilities for long-term human space exploration. And it helps us understand life here on Earth a little better, too.
Our job, working on the space station, is to go up there and perform science experiments and try to discover new things, whether those are new materials that might help people on the ground or those may be new medical breakthroughs that might help people on the ground. And so we're up there constantly kind of pushing the boundary of what we know, helping the scientists on the ground make those breakthrough discoveries. It's allowing us to learn more about ourselves, the human body, about the universe around us, and how to improve life on the ground, and also how to take those discoveries and push further into the unknown, into space.
Before embarking to a place where very few humans have been, astronauts train for 2 years. In that short time, they're required to learn a lot more than you might expect.
Astronaut training in a nutshell is you need to be a jack of all trades. You need to be able to do a little bit of everything.
Repairing and servicing the International Space Station, learning Russian, and receiving medical training. Astronauts must be prepared for every possible scenario. But before an astronaut ever sets foot aboard the space station, they have to train somewhere you might not expect. This isn't just any old swimming pool. It's the Neutral Buoyancy Lab, located at NASA's Johnson Space Center in Houston, Texas. This special pool contains 6.2 million gallons of water, enough to fit 9 Olympic-sized pools inside. It's where astronauts like Nick come to train.
So the pool is this gigantic pool. It's 200 feet long, it's 100 feet wide, and it's 40 feet deep. It is enormous. It's still not big enough to fit the entire space station in it, but it fits full-scale, large chunks of the station so that we can practice, and that's our training ground.
The pool is where astronauts first get acquainted with the armor that protects them from space, their spacesuit. And that can be its own challenge. First thing, you've got to suit up. It can take about 45 minutes and the assistance of multiple suit technicians to get the suit on, checking to make sure that every piece is fitted and working properly, from the helmet locking into place to the gloves fitting around every finger.
You have to learn how to use the spacesuit because it's not like wearing clothes. It's constraining and it limits some of the things you can do. It's fatiguing because of the pressure of having it stiff, and so you have to learn how to use it, and that takes hours underwater getting to know your spacesuit.
Once you have the suit on and it's been double and triple checked, you can prepare to enter the Neutral Buoyancy Lab. Even though you're not out in space just yet, the pool will simulate what you might feel once you're out there. Why? Because being underwater simulates weightlessness.
The Neutral Buoyancy Lab is there to train us because that's one of the places or one of the ways that we can try to simulate being weightless. So that idea of neutral buoyancy.
It's called neutral buoyancy because when you're in water and you don't sink, but also you don't float, you're completely neutral. It's like you're hovering in place.
And so it feels as though I'm weightless, and I can maneuver myself around the outside of the space station and have the experience of working in a weightless environment. And so we're constantly trying to balance out the weight of an object with its buoyancy so that things just float in front of you.
Weights and flotation devices are carefully combined to let astronauts feel what it's like to be weightless in space. When an astronaut is training in the pool, their backpack, the primary life support subsystem, is filled with air they can breathe and instruments that monitor their health.
You've got to get everything straight because once you go underwater, that's all you've got are the tools you took with you. And you're going to be down there for 6 hours.
That's about the amount of time it takes for a spacewalk in actual space. Once you're in the pool, waterproof instructions are attached to your arm, and you rehearse the spacewalk as if you were doing the real thing.
All right. Nick, before we get started on that, if we can just help me guide that out. Much appreciated.
The whole time, a team of people is watching every movement of your practice spacewalk. They monitor the pressure inside the suit and the temperature. And the test director is making sure that the whole process is going according to plan.
Good teamwork there. Exactly.
So I need to float a little bit higher on this end. Okay, so that's good alignment.
Trained scuba divers guide you around a replica of the outside of the International Space Station.
Yeah, and that looks good here. Yeah, we're aligned down here. Okay.
Having this full-size mock-up of the space station underwater allows us to essentially memorize where every handrail is, where every handhold is. And if I'm going to work in a particular location on orbit, I will have seen that and understand that location on the ground.
Astronauts are explorers, and a pretty big part of their job is going on spacewalks.
We practice doing spacewalks so that when we need to go outside and fix something or increase a capability, add some new piece of equipment, we're ready to do that.
During a spacewalk, the only thing that stands between an astronaut and the vacuum of space is their spacesuit. And while they're attached to the outside of the International Space Station, they're orbiting the Earth at 5 miles a second. That's like driving from Boston all the way to Philadelphia in just 1 minute. It's difficult to replicate the sensation of being in space. But with the Neutral Buoyancy Lab, NASA can get pretty close.
I got to tell you, when I did my first spacewalk, shortly after we went out the hatch, the sun set and it got dark, and it felt exactly like I was in the pool. To the point where I remember having the thought go through my head, where are all the bubbles? Because normally in the pool you see all the bubbles from people breathing underwater. It was one of those things I was like, wow, this is so close to what we're doing underwater in the NBL. It's just amazing training.
Space is unforgiving. Without the protection of the Earth's atmosphere, the temperature can either soar or plummet by a range of over 500 degrees. And there's only a little bit of time to get through your to-do list. 6.5 hours is the usual ballpark for a spacewalk, and that might sound like a lot of time, but remember, there's a finite amount of oxygen in your tank. You need to keep track of the power in your battery and monitor water for spacesuit cooling. And most importantly, you have to watch your carbon dioxide levels. The longer you're in space, the more likely you are to get hit by flying debris. Micrometeoroids are a spacesuit's worst enemy. Even a piece of metal that's as small as a grain of sand can puncture your suit, which could cause air to leak out. Astronauts train for a wide range of scenarios they might encounter during all phases of their journey, from launch to the return to Earth. There's a lot that could go wrong, and Nick knows that firsthand.
3, 2, 1, and there is liftoff of the Soyuz MS-10 to the International Space Station, carrying Nick Hague and Alexei Ovchinin. This again is Nick Hague's first launch to space and Alexei Ovchinin's second.
We train so that we can respond to the unknown. We are constantly not just training for when things go right. We're constantly training against what we can predict will go wrong. In the training scenario, we're fighting 5 or 6 different major failures so that we have the bandwidth to be able to, on a real flight, to handle the one big thing that's thrown at you.
Hearing there that there has been an issue with the booster, and we're standing by for information as we continue to get it from the Russian flight control team.
I can tell you, in that moment, when life throws something at you like that, it is amazing how you just revert into that mindset of, hey, I was being vigilant up to this point. I've diagnosed something that's wrong. We know what we need to do. This is our best way of being successful. And then you follow those procedures as best you can. And you're able to kind of block, a lot of the other stuff out and focus on just what you need to do to survive.
Everything seems to be fine with the crew. We had good comm with them, and they are okay. We continue to wait for more information.
At that moment, Nick remembered his training.
We had an in-flight abort. We recovered from that one, and I was able to launch successfully to the space station about 5 months after that.
Nick ended up having a successful and productive trip to the International Space Station, thanks in part to his training at the Neutral Buoyancy Lab.
The International Space Station, that international aspect of it is really a powerful part of the program. You've got astronauts that have been from 19 different countries, astronauts and cosmonauts working up there together. We've been able to perform 2,800 different experiments from researchers, like 4,000 researchers from over 100 different countries. It has this ability to bring all of these very different people together in pursuit of that common goal of increasing human understanding.
Nick returned to Earth last fall, and he treasures his memories from his time in space.
What it has really taught me is that when we understand this common purpose and when we work shoulder to shoulder and elbow to elbow with each other, we start to realize we have so much in common. And that gives us the foundation to be able to not necessarily look past differences, but to look at those differences and the diversity that comes to the team because of those differences, and to celebrate those differences. And so the approach that we've taken on the station in the 2 decades of collaboration in space, in the pursuit of knowledge, that's something that we're going to continue to carry forward as we go to the moon, as we develop the Artemis program, when we start to explore the surface of the moon, and as we take what we learned there and we push on to Mars. I think ultimately that's the amazing part of going to space. That's the real motivation. It's such a powerful, positive example of pulling us together and accomplishing something great.
In the coming years, astronauts will continue to push the boundaries of human space exploration. The Artemis program will send the first woman and the next man to the moon. An important part of NASA's Artemis program is setting up sustainable architecture on the moon's surface. Here on Earth, astronauts are already practicing how to move around, set up habitats, collect samples, and deploy experiments just like they will on the moon. We have a lot to explore on the moon and Mars, but the Artemis astronauts' first stop will be the pool. The Curious Universe team includes Elizabeth Tammy and Michaela Sosby. Our executive producer is Katie Atkinson. Special thanks to Thalia Petrinos, Eric Land, Gary Jordan, Brandy Dean, and Ryland Heggie. If you liked this episode, please let us know by leaving a review, tweeting about it at NASA, and sharing it with a friend. And join us next week as we meet NASA's spacecrafters, who use some surprising tools to prepare missions for space.
One of the reasons I sew is it's therapeutic. A lot of times if there's something that's troubling me or I need to think about it, I will design something and sew it. It's being one with yourself. It's just you and the sewing machine. I love that hum sound, the hum of the sewing machine. It calms me. My name is Paula Kane, and I make clothes for spacecrafts.
We need long pants and jackets to keep us warm when we go outside on cold nights. In a way, NASA spacecraft do too. It's really important to craft protective coverings for the probes that leave Earth to go exploring. And the people who create them use tools you might not expect to find around a Space Center laboratory. Sewing machines, tape, and scissors. Welcome to NASA's Curious Universe. Our universe is a wild and wonderful place, and in this show, NASA is your tour guide. This week's adventure takes us to some very creative places here on planet Earth, NASA's Thermal Blanket Labs. We're meeting NASA's spacecrafters, the technicians whose work helps protect our missions from the harsh environment of space. Just as you might visit a tailor to get your pants hemmed or your suit fitted, NASA calls on thermal blanket technicians to custom make the protective shields necessary for space exploration.
Thermal blanketing is basically like clothes for spacecrafts.
But it's different The thermal blankets are a multi-layer installation that either protect the spacecraft from heat or cold.
They're custom made, custom designed. The outer layers can be a little bit thicker like aluminum foil. The internal layers feel almost like tissue paper. That's how thin they are, and the netting is no different than what you would make a bridal veil out of. It's just space grade.
And I will show you what they look like.
If you look at pictures of spacecraft, many of them are covered in what looks like gold foil. These are called thermal blankets.
What a thermal blanket technician is a person who works with blankets. And the blankets are layers of film. Anything that goes in space either needs a special coating or these blankets on it. And what I do is design the patterns and everything and make these actual blankets, cut them up and tape them and apply them on instruments, satellites, whatever needed.
Rarely is it silent in the lab. You'll hear hammers punching, you'll hear vacuums running, you'll hear the sewing machine going.
This machine was built to go very fast, but what we do, we have to go very slow. Like this.
Those are the voices of thermal blanket technicians. Lots of NASA missions would never leave the ground without their creativity and handiwork. Thermal blankets protect spacecraft from extreme heat and cold that could damage them. These special coverings can also defend NASA missions against collisions with micrometeoroids, very small chunks of rock or metal flying through space. The technicians who work at NASA's thermal blanket labs, and for our commercial partners, collaborate with NASA engineers to figure out how to best cover space hardware of all shapes and sizes. Each thermal blanket is different, ranging from 1 layer to 30, or even more. The technicians who model, prepare, and design thermal blankets have to be able to craft incredibly precise templates. These problem solvers work with their hands and use a variety of materials like netting, Kapton tape, markers, sewing machines, and even surgical scalpels to execute mission requirements. Many of NASA's thermal blanket technicians have a background in the arts, like Paula, who went to fashion school.
I was born loving sewing because of my mother. My mother sews, and growing up, my mother used to watch the soap operas. And she was a stay-at-home mom, and she loved Young and the Restless. And if you know anything about Young and the Restless, especially back in the day, they used to wear real elegant, fancy clothes, suits, that type of thing. And my mother would look, and she'd look down at me, she says, "We're going to make that today." And then we'd go to the fabric store, we'd pick out the pattern, the fabric, and then she would make it. And I was like, I want to do that too. So from watching her, and then she taught me how to sew, it just inspired my love of sewing and designing. And then from there, I decided to go to school for fashion design.
There was always a part of her that was fascinated by NASA.
I always kept up on the latest fashion design stuff because my degree is in fashion design. And they had a job under fashion design. It said, do you like Star Trek? And are you a Trekkie? And I was like, uh-oh, because I love Star Trek. And I looked at it, and it said something about a thermal blanket technician. And I called, and it was here at NASA. And I went for the interview, and I was like, oh my gosh, I got behind the gate. Walked around, they showed me the facility and what I would be doing, and I got the job.
It takes people from all kinds of backgrounds and areas of expertise to make a NASA mission possible.
The range of the backgrounds that people come from for a thermal blanket technician is interesting because mine is sewing and design. We have a person who's a graphic artist background. We have a person who, she did draperies, that type of thing. Their ideas are a little different, which is good. You need different here. You've got to think out of the box. Sometimes you can't always draw everything out, so you have to be able to think about it in your head. Like, how will that unfold? How's that going to fold up? How is that material going to work? How are you going to cut it? And be able to do it sometimes a little bit quicker than you would want to. So you got to think on your toes.
Paula's experience in the fashion industry prepared her for a job at NASA. But that didn't mean she wasn't nervous at first.
When I first started here at NASA, I was very nervous my first day. I remember it like it was yesterday. I was like, oh, please, don't let me mess up on anything. I remember saying a prayer. And I said, my father always taught me, if you don't know, you ask. Don't mess anything up. You ask first. So I said, as long as I remember just to say, I'm new, and can you help me, and that type of thing. And it was interesting because when I first came in, one of the very first projects was working on the servicing mission for Hubble. To me, personally, when I think about NASA, I think about Hubble. I mean, I grew up looking at some of those pictures and piquing my interest about space and what's out there. So to come in new, my first week, I was doing something on Hubble. Heart was in my throat again, but I just took my time, and the people in the blanket lab were very helpful.
Paula rose to the challenge and hasn't looked back since.
I've been here at NASA for 12 years. And I thought I was only going to be here for about 3. I said, I'll give it about 3 years. Then I'll go back home and work at home. And I loved it so much, I've stayed. I get a special feeling knowing that things that I have made, things that I've touched are up in space, because I think about the fact there's not that many people in the world who have that opportunity. And this is something that I basically do every day. I feel a little special, It's like, I may not look like it, but, I've got stuff up in space.
Thermal blanket technicians like Paula have helped prep a variety of missions, like the upcoming James Webb Space Telescope and Parker Solar Probe. They get to be involved in a range of projects.
I am a person who does not like to do things over and over again. And working here is different almost every day. And I think that's what keeps me here.
Over at NASA's Jet Propulsion Laboratory in California, Lynn Pham has been making thermal blankets for almost 20 years. Before that, she emigrated from Vietnam and worked as a seamstress in Los Angeles.
When I started, I got paid $2.10, but then it's piecework. That means the faster you make, the more you make money. So I got up to $5 an hour. So it was pretty big then. That was 30 years ago? Over 30 years ago. Wow.
Lynn decided to go to trade school to learn about making electronics. By the time she started working at JPL, Lynn knew how to cable and solder. She could structure wires and work with metal. Those skills, combined with her sewing background, made her a good fit for thermal blanketing at NASA.
I would never imagine that I came here, got to work for NASA and send something to space. I would never dream or think that I could be able to, with my talent, that I could be able to work something this big, this great.
During her first year at JPL, Lynn was able to apply her cabling skills to the Cassini mission, the first satellite to orbit Saturn. Through cabling, Lynn's hands touched spacecraft that traveled to Mars. But it was a little harder for Lynn to see the full impact of her work because she never saw the end product until she became a thermal blanket technician.
I like blanketing because it's from beginning to the end. I got to see, I got to fabricate it, I got to install it, and that was the last step before it goes. So it's from my job from beginning to the end versus the cable, you only build and you don't know what after that. Yeah, I got to follow all the steps throughout, the tests and everything. So it feels more like you see what, like that you have a baby, right? You conceive it and you see it come up, and then she's grow up and gone. That's how I feel about what I'm doing, thermal blanketing.
Although the missions Lynn worked on felt like her baby, her own children had a hard time understanding what it was their mom did.
I tell my kids when they're little, they ask, what are you doing? I keep explaining, and they couldn't understand. I said, just think of it as I'm making dresses for you. So I make dresses for the spacecraft.
With thermal blanketing, Lynn was able to see the whole process. Dressing spacecraft for flight gave Lynn a new sense of curiosity for the missions she worked on. The Mars rover's spirit and opportunity really impressed her.
The Twin Rover, that's when we got a lot more public exposure. Then I realized more that, oh wow, this is really big. Something, out of my imaginary. I always say, how do they calculate it that it landed right there? That's amazing.
So much of what NASA can do is only because of the hard work of employees at all stages of a mission. For Paula, the teamwork at NASA means a lot.
It's fun and refreshing that you work with a team. And even beyond the team that's in the blanket lab, everything that we do here in NASA, it's hand in hand. We're all one big team because you can't do one thing without the other. And that's what I love, because it shows you just how it should be, I think, in the world. You have to work with everyone to get along and to get things done.
Spacecraft really can't survive in space without the careful work of the people who create their protective coverings. Think of it as choosing just the right outfit to wear before stepping out into a blizzard. If anything is out of place, you'll find it hard to function. NASA's spacecrafters are making sure our missions are prepared too. They sew the blanketing and dress NASA's missions up before they begin their journeys in space, where they'll be safe and bundled up and ready to get to work. This is NASA's Curious Universe. The Curious Universe team includes Elizabeth Tammy and Michaela Sosby. Our executive producer is Katie Atkinson. Special thanks to Colin McNutt, Leslie Mullen, Liz Landau, and Ryland Heggie. If you enjoyed this episode, be sure to share it with a friend and rate and review us in your podcast app. And join us next week as we step into the field. Snowmobile rides, deep sea dives, forest hikes. NASA experts travel to some amazing places to learn more about our planet. In this bonus episode, join Jessica Mersdorf, science writer, on her journey to Grand Mesa, Colorado.
When you step off the snowmobile and you're looking around you, you are in a flat, vast expanse of white. Small clumps of trees here and there, but your first sensation is of this giant tabletop of perfect, pure white snow. My name is Jessica Mersdorf. I am an earth science writer, and I just spent 3 days out in the field. A field campaign is when scientists are measuring something in the Earth environment, typically, where they have to physically go and be there and take those measurements themselves. A field campaign can take place on an island or by the ocean or in the snow or on a mountain. NASA scientists go all over the world and to all sorts of different environments, from the very hot to the very cold. I went to Grand Mesa, Colorado with the SnowX 2020 team. SNOWX is a project that is researching snow properties, so depth and density, particle size, that sort of thing, using a variety of different instruments on the ground and from the air. NASA's interested in snow for a couple different reasons. It's really important to the Earth's ecosystem. It regulates temperature and climate because it reflects sunlight back out of the atmosphere. And it's also important from a water perspective. If you live in an area where you get a lot of snow, you may rely on snow for your drinking water during the spring and summer and fall. When solar energy comes in, the snow reflects some of it back out. It also absorbs some, and the amount of snow and how reflectant it is plays an important role in regulating Earth's global temperature. My job on the campaign was to simply record what the scientists were doing. What are the scientists doing in the morning? What does the sky look like today? What is the weather? Every day, or almost every day, I tried to record an audio diary.
My name is Jessica Mersdorf. It is very late at night, and I traveled for 12 hours today. I'm very excited. I'm excited to tell the story of our NASA field campaigns because science, really, it's a dynamic process. It's a living process with real people.
This was my first field campaign, and I wanted to capture as many of those memories as I could. I wanted to remember what I was feeling like on each day, what was I nervous about going into it, what was unexpected.
Tomorrow night, I will be up at Grand Mesa, so looking forward to checking in then.
The scientists' daily field locations could only be accessed by snowmobile. The morning that we were supposed to take the snowmobile ride happened to be the morning that we were recovering from altitude sickness. So I came down to the lodge that morning very nervous about getting onto a snowmobile. In order to cover as much ground as possible, the team drove very quickly. So we got on the snowmobile. We went up very steep hills. We went around very sharp curves. We would hit bumps that would throw you up and down. When you get off the snowmobile and you're standing near the field site, you really have a sense of standing on this giant white tabletop where there are no other humans in the world except for the people you have around you. SNOWX has two components. There's the airborne component and the ground component. In the air, our primary instrument is called SWESAR, Snow Water Equivalent Synthetic Aperture Radar and Radiometer. On the ground, the measurements that are taken by SWESAR are also taken by scientists on snowmobiles. Scientists are driving in very tight clockwise spirals in the snow. And they wind up with these giant crop circle looking things. The pits are often dug in the center of the spiral, and then they would sit in the snow pits and take the rest of these measurements by hand. The SNOWX team had 146 planned snow pits, and they wound up with 153. You'll see scientists around the pit who are on skis or on snowshoes. They're taking additional measurements of snow depth, snow particles, and so forth that you can't take down in the pit. The snow pits are important because some of the scientists' measurements have to do with the layers in the snow and how it changes from the surface down to the ground. The snow that's up on top is very light and fluffy. It's fresh, it's new, it's just fallen within the last couple of days. If you go down a little bit, there's a layer where it's been packed tightly by the wind. Further down, it's even more dense, and there's more water in the snow that's closer to the ground. When I was up there, I felt a lot of conflicting feelings about the landscape.
This is Jessica. I think it's around 11 o'clock Thursday morning. It's been... I don't even know how to describe how this experience has been. It's been harder than many things I've ever done in my life. Adjusting to the altitude, adjusting to the temperatures. It is a very harsh environment up here. It is cold, the wind blows.
Part of me was very cold, put off by how isolated it felt, by how there were so few people up there. The people that you're out there with really do feel like your lifeline. I've never been in a place where everywhere you look is just as beautiful as what you saw a moment before.
It's been so beautiful and rewarding, and getting to just see the energy of these scientists who are out here in these conditions for a week, 2 weeks, 3 weeks, collecting this data. It's mind-blowing. I'm really proud of myself. I'm really proud of the way that I've adjusted and adapted and stuck it out and tried new things and gone new places. And, you know, part of me is really excited to get home to the warmer temperatures and back to sea level elevation. And another part of me is really sad to leave, because there is something magical up here that I have never found anywhere else.
This is NASA's Curious Universe, and you're listening to our Field Notes series, where we send scientists and science communicators into the field with a recorder. If you liked this episode, please let us know by leaving a review, tweeting about it at NASA, and sharing it with a friend.
We're very used to the sun. It's our star. We see it in the sky every day. We know that it has a lot of impact of what happens to us here on Earth. But of course, it's even more than that. The sun actually shapes our entire neighborhood as we orbit around the Milky Way. Understanding the sun and how it works is very, very fundamental to us.
This is NASA's Curious Universe. Our universe is a wild and wonderful place. I'm Patty Boyd, and in this podcast, NASA is your tour guide. This week's adventure takes us to the very center of our solar system. We're visiting our neighborhood star, the Sun.
For me, what makes the sun really cool is it's kind of like having a star in your backyard. Hi, I am Nikki Fox, and I am the director of NASA's Heliophysics Division. You know, we're used to looking up at night and seeing all the beautiful stars, beautiful constellations, planets glowing, and it's all wonderful. And then you realize the sun is just like an average star, but it's very close to us. And so, number one, it means that we can study it in very, very, very detailed ways. But also, because we live so close to it, we kind of live in the atmosphere of the sun. If we can understand our star, then it helps us understand stars in other solar systems or stellar systems. So everything's happening in heliophysics.
The sun is responsible for life as we know it. Its gravity holds the solar system together, keeping everything from the biggest planets to the smallest particles of debris in its orbit. But it also drives a vast space weather system of particles that weave through space. And that's what NASA's Heliophysics Division studies.
The sun's outer atmosphere actually moves all the way out through the edge of our solar system. That's actually what's creating this boundary. And so we live in the atmosphere of the sun. So when the sun is a very, very active star, that actually drives what we see here at Earth.
Earth is orbiting through a space soup of solar particles. The interactions between the sun and Earth create a complex space environment. It drives effects from the beautiful to the detrimental. It creates aurora, but it also interferes with satellite electronics or GPS signals. That soup of particles also protects us. It extends billions of miles out, far past the last planets, and we wouldn't be here today without it.
The sun creates this protective bubble that really protects us from all of the vagaries of interstellar space. So all the nasty things that are outside are kind of kept at bay by this atmosphere and this boundary that the sun creates for us. The sun is very dynamic. It's an exciting field to be in because the sun changes every day. So you always have something new to study. But for me, the big attraction about studying the sun is it's studying a star. And right now, it's the only star that we can study up close.
The sun is our closest star. It's our protector, our life giver, and it's also our only close-up and personal glimpse into star science overall. Though we see the sun daily, there's a lot that would surprise you.
I think a lot of people look at the sun and just think it's a bright, ball of light, or some people think it's a bright ball of fire in the sky. But the sun is very complicated.
Our star is actually a hot ball of glowing, electrically charged gas, and it's made up of many different layers. Let's break them down. Our star has a core. It's not solid, and it works kind of like a nuclear reactor. Nuclear fusion happens there, producing all of the energy that eventually makes it out of the sun as light and radiation. After that comes the radiative zone. It's the region where things literally radiate out of the core. Then there's the convective zone, where the sun begins to act a bit like boiling water.
Then there is the kind of visible, what we think of as the visible surface. We call it the photosphere. It's not an actual surface, it's not solid, but it's what our eyes see as the kind of outermost region of the sun. However, there are two more layers. It's just we can't see them because this visible surface is so bright that you can't see those hazy layers.
These layers are the chromosphere and the corona. We can't see them because the visible light is so bright, making these layers seem hazy. The corona in particular is especially crucial.
The most important thing for us here at Earth is the corona, which is that bright, hazy atmosphere that you see during a total solar eclipse. That's the only time you can see it because finally the moon blocks out that bright point of light that we see, and you can see that beautiful corona around it. So the sun is a lot more complicated than you might think by just looking at it from here at Earth.
That solar atmosphere, the corona, that's what's driving all the changes in space throughout the solar system. While the corona affects us the most, it's still the most mystifying part of our sun.
The corona, it is extremely hot. It's on average 2 million degrees.
That's Aleda Higginson. She's a heliophysicist at the Johns Hopkins University Applied Physics Lab.
The weird part is that it's actually hotter than the surface of the sun. So colloquially, we all talk about how, oh yeah, the surface of the sun, like that's some really hot big number. And it is. 6,000 degrees is really hot, but then you multiply that, and that is what the atmosphere of the sun actually, how hot it actually is. So that is something that you cannot have a physical grasp on as a human.
The corona's high temperatures are a bit of a mystery to scientists. As you move away from the surface of the sun, the temperatures actually get hotter. Imagine sitting next to a campfire, but then feeling warmer as you walk away. It may sound strange, but this is exactly what seems to happen in the sun. And heliophysicists have been trying to solve this mystery for a long time.
The sun is incredibly violent. It's aggressive. So if you could fly next to the sun, you would be blinded by the amount of light that it's putting out. You actually probably wouldn't, if you could magically survive in a vacuum. You might not feel the heat from the material surrounding you as much as you would just feel the heat from the radiation of the sun. So the front of you would be really hot and the back of you would be really cold, because even though we have all that material in space next to the sun, surrounding the sun, it's not very dense.
Our star is not a burning ball of fire. It's plasma, a soupy mixture of electrically charged gases, mostly hydrogen and helium. The sun is made of 90% plasma. Its unique makeup means that the laws of gravity, the force we experience most on Earth, is only one of the forces driving how particles move. So all that plasma moves around unlike anything we have normally experienced on Earth. Our sun is an active star. It releases a constant stream of that solar material, the plasma, in all directions at all times. Our star's activity creates what we call space weather.
Space weather is the term that we use to define all of the dynamic activity. The sun's activity makes its way through space and then impacts the Earth system.
NASA cares a lot about understanding space weather because it can be very disruptive. It can trigger power outages and disrupt GPS signals. It can also affect astronauts and spacecraft in space.
It also can change in a really large way, really suddenly. So you can have several days of just kind of background, low-level variation in the space weather activity, and then suddenly there'll be a huge eruption on the surface of the sun, and then that can, within a matter of minutes, cause all kinds of interference here at Earth just from the radiation from the sun.
The sun impacts us here on Earth, and it's also a laboratory for understanding the stars far beyond our solar system. Scientists like Nikki and Aleda are working to unravel the mysteries of our star.
There are a couple of mysteries we've known about for, well over 100 years. The corona, this hazy atmosphere, it's hotter than the surface of the sun by about 300 times. And that doesn't make sense. We call it the coronal heating mystery. What is it that's happening that's actually causing this heating? And we've known about these questions, but you can study the sun from all different kinds of wavelengths, which we have done. We've sent spacecraft in as far as the planet Mercury, and we've done amazing science, but we've never really been able to go and visit exactly where this heating is happening.
In 2018, NASA launched a mission to touch the sun.
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
Parker Solar Probe, a mission headed to explore the unknown. It's on a voyage of discovery, and it's looking for some answers to those big questions.
Parker Solar Probe is actually flying in to the sun's corona, making cuts through the sun's corona very close to the sun, and is already returning amazing data to us.
It's getting closer to the sun than humankind has ever sent a probe before. And it's actually going to be touching the very outer layers where the corona transitions to the solar wind, and studying the mysteries that are there and trying to understand why is the corona so hot? Why is the sun's atmosphere so hot? We think we know where the energy is coming from, but we just don't know how it's getting there. So that is something that we're hoping Parker Solar Probe will be able to shed light on, and is one of the biggest questions that will probably have some important implications for physics in general as well, not just for space weather and the sun.
There's a lot to study with heliophysics. There's many, many different aspects of it that you can study, and it's a great time to be a heliophysicist. We're launching great missions to all these key locations. Some people say, it's a new discipline of science. I would say it's the original discipline of science. Everybody looked up at the sun at some point and wondered what it was and how it affected us. And that's what we study in heliophysics.
There are billions of stars like ours scattered throughout the Milky Way. But the sun is incredibly important to us. It's ours. And it affects so much of what we experience here on Earth. We still have plenty of questions about the star in our backyard. With each day, NASA's sun scientists gain a new understanding of it and get a little closer to unraveling its mysteries. This is NASA's Curious Universe. The Curious Universe team includes Elizabeth Tammy and Michaela Sosby. Our executive producer is Katie Atkinson. Special thanks to Karen Fox, Sarah Fraser, and the Johns Hopkins University Applied Physics Lab. If you liked this episode, please let us know by leaving a review, tweeting about it at NASA, and sharing it with a friend. You can also tag along on more solar adventures by following @NASASun on social media. Thank you for listening to the first season of NASA's Curious Universe. Our universe is a wild and wonderful place, and we've enjoyed exploring it with you. We're taking a break now, but we'll be back before you know it. Until then, you can continue exploring the universe and discovering our home planet with NASA by visiting nasa.gov. You can also follow NASA on Twitter, Instagram, and Facebook. And find more NASA podcasts in your app or at nasa.gov/podcasts.
Houston, we have a podcast. Welcome to the official podcast of the NASA Johnson Space Center, episode 154, The NASA Worm. I'm Gary Jordan, and I'll be your host today. On this podcast, we bring in the experts, scientists, engineers, astronauts, even artists, all to let you know what's going on in the world of human spaceflight. The worm is back! Now, before you start practicing your dance moves, I'm talking about the NASA Worm logo. You'd recognize it if you saw it. It's that retro-looking logo where NASA is spelled out in red. We call that one the worm, and the blue one is called the meatball, at least informally. In the official NASA style guide, the meatball is called the insignia, and the worm is called the logotype. The worm has been retired for almost 30 years, and any official NASA product in that time has been branded with just the meatball. But just prior to the launch of NASA's SpaceX Demo 2 mission in May 2020, NASA brought back the use of the worm, and it's now being used for select missions and products. The worm design is super famous, and even though it's been retired, it's still very much part of pop culture. With a new era of human spaceflight upon us, the worm is making a comeback. So to describe this logotype and its history is the very man who designed it, Richard Daney. It was he and his firm, Daney and Blackburn, that was selected for NASA's rebranding in the mid-70s. Richard is an extremely experienced and award-winning graphic designer, and on this podcast, he describes the journey from the worm's creation to now, and what it means for NASA's future now that it's back. So here we go, the NASA Worm logotype with Richard Daney. Enjoy.
T-minus 5 seconds and counting. Mark. Launch commit lights are correct. Here she goes. Houston, we have a podcast.
Richard Daney, thank you so much for coming on Houston. We have a podcast today.
Hey, Gary, it's great to be with you, and thanks for the invitation.
What an honor to be talking to you, sir. The person who invented such an iconic logo. I want to take it from really the very beginning, really just a brief, summary of your biography up to the time that you started working with NASA, just to understand who you are and where you come from.
Okay, sounds fine. Well, I have an unusual background, so I'll just very briefly give you some of that history. I was born on a farm in Oklahoma, and believe it or not, in 1934. Well, that's a significant date because, it's the middle of the Great Depression. And the overlay, which was quite fierce, was Dust Bowl, Oklahoma. And frankly, Gary, I don't recommend that as a start. You know what I mean? But on the other hand, it was a great beginning because everything went up from there, upwards. So I was the youngest of 4 children, and I was a good student and very involved in music. I played in all the bands and even in a jazz quartet in high school, which is great fun. So we worked high school events and dances. We had no art, but I drew constantly. So, this was an early warning of what I was going to do with my life, I think. And then we went on to college. Of course, I attended Oklahoma State University. Started in engineering, which was something my folks wanted me to do at OU. I didn't like it, although I think it's played a great role in my career, frankly. so I don't feel it was wasted time. I switched to art because no design was offered at Oklahoma State. I also had a jazz quartet in college. I came literally within a whisker of pursuing music as a career. I'm awfully glad that I chose design. But I did know that OSU was not proper background. It wasn't good enough. So one of my professors helped me get located at UCLA grad school. So immediately on my graduation, I drove straight out to UCLA and started specializing in design. Thank God, because it all worked. So it was great. And then the other caveat to this is I began my freelance career in Dallas, and my entire 6-decade career has been independent practice. I'm very proud of that. So then on to New York in 1963, and that's when we really got involved in some of the really big stuff.
Like what? What were some of the first things that you started tackling?
Well, we did real life before NASA. It was, I was freelancing, so I started with anything I could get, book jackets and peripheral stuff like that. However, we very quickly got into corporate work and worked with people like U.S. Information Agency, and they're in Washington, and General Dynamics, which kind of got me into this world of aerospace, so to speak. Ford Foundation, Time Incorporated, worked for Westinghouse, and, some really good names. So at that time, the field was wide open, and for someone like me to start freelance in New York was almost unheard of. Or you wouldn't do it today, let me say that, Gary. It just would be impossible. But that was sort of the background, and it all happened pretty fast. I'm not to say it wasn't hard work, but it was great. It was a lot of fun, too.
So, it sounds like you got into the world of aerospace even early on in your career, but I'm kind of curious. You said you were drawing back in Oklahoma. What were those things that you were drawing? What were you interested in putting on?
That's pretty interesting. That's a great question, actually. I was drawing mostly cars.
Huh.
And I could have gone in that direction, too, automotive design. Of course, I do planes, too, and athletes. It was the era of Bud Wilkinson at Oklahoma University, and so, great football teams, and I draw all the athletes. But I think I just kept returning to cars, and I carved them, too, out of wood, and it's real modern designs that people really thought were very ambitious and great stuff. But, I think it was all pointed in this direction, It wasn't...
Yeah.
It wasn't exactly peripheral. It was really good.
Very much so. See, I could see maybe about that push from your parents to go into engineering, but you said that just didn't work for you. It was you were more passionate about art. What was it about art, or maybe that a lack thereof within engineering, that made you want to pursue the path that you did?
Well, in college, and of course you meet all the other students, and you become acquainted with what's being offered. But I always had the music and art. That was really my thrust from the time I was a little boy. And as I say, I carved stuff constantly. I was always drawing. So in college, I became aware through other students what they were doing. And I just thought they were having a lot better time than I was. And I did have quite a bit of ability. I could paint. So I started looking into that program, and I actually switched in my sophomore year. And I was very happy for the rest of the college experience, but I still wasn't meant to be an engineer. And what's fascinating about that is, and we'll get into this later, but I've worked with engineers and scientists a great deal of my career. It wasn't just NASA. And so it all fits. I think when you have that orientation, or I could have done that, it's a platform kind of thing, and it's a good place to start from, a good launch pad, if you will.
Very nice. I want to skip ahead to NASA. The kind of the base of this is this logo, but to sort of give a little bit background for our listeners, we're talking about two logos that are the I guess, identifiers of NASA. Can you describe what they are and what they look like?
Yeah, there are two marks for the agency. There was only one then, and it was called the meatball, affectionately called the meatball. And it was a blue sphere with a kind of a chevron shape in it, a wedge shape, with ellipse around it and a sprinkling of stars in the middle. So it's very allegorical, sort of a storytelling symbol. When we came in with the design, when we saw the cross-section of work being done by all the centers, we went the other way and decided we needed something very, very simple that could anchor the whole program. But so the worm, which is also an affectionate term now, the logotype, is a warm red logo with custom letters, which, of course, are one-stroke letters, suggesting technology, propulsion, lift, and our intention was to try to suggest the future without hyping it, and make it very, very useful, and that's the way that worked out.
So let's dive a little bit into the history here.
Sure.
There was a transition point, from we talked a lot on this podcast about just the Apollo missions, and if you were to watch any of those missions, that meatball that you're discussing, that was the logo. That was the one that everyone was tied to.
Exactly.
But around, I believe it was 1974 was the time that you started coming in, and they were looking for a redesign. Tell me a little bit about that.
The Apollo program, which, by the way, I was glued to the set all the time. So since I'm a little boy, I love flight. And then, of course, space exploration just hooked me completely. So I did follow the Apollo program and was very involved before we got the call, so to speak. But for the agency, there were no easy headlines after Apollo. There was no publicity coming automatically. And it was a very quiet time for the agency, and I think they were very nervous, anxiously awaiting, really, the shuttle program to kick in. And I can understand it because it had been so easy with the Walter Cronkites of the world, hyping it, making it happen. But this was very quiet. I think it's one of the reasons that this program was initiated was to fill that void. But it really wasn't designers' idea. It was the National Endowment of the Arts. They created the NEA short. They created a program called Federal Design Improvement Program. And they felt that federal graphics were very weak and behind. And of course, that's true. So they took it upon themselves to do research missions on every agency and collect archival data and everything that the agencies were doing. Then they evaluated it and decided whether the agency should have a redesign or not. And one of the very first ones they wanted to attack was NASA, and the reason was it was such a high profile, and so they thought if they could get an early victory with NASA, then all the other agencies would follow, and of course that's exactly what happened.
So, that was a big deal then. This was very forward-leaning at the time. So how did Dane and Blackburn get selected?
Well,
Daney, sorry.
We were only formed the fall before we got the call, and so that would have been in 1973. Daney and Blackburn was less than a year old when we got the RFP. But my partner, Bruce Blackburn, had been with Sherman Guys, a rather famous firm, and he had recently designed the U.S. bicentennial symbol while he was there. And NEA was very, very fond of that mark. And I think to this day, I believe that was the main reason that we made the short list. And it's interesting, Gary, that at that time, because it's also new, they only invited about 7 or 8 firms. Down the road, and we did a number of other programs, it just kept growing geometrically. So, each time they almost doubled the number of candidates they brought in to bid on the jobs. But we were, as I say, so we were called very early on, and I think bicentennial was the key.
Wonderful. Now, when they did bring you on, I'm sure they had some visions of what they wanted. What were those key elements they wanted? You already mentioned a few. They wanted it future. They wanted it something about lift. What were those key elements they wanted for this new design?
Well, it's interesting because I don't know that NASA, and I think they were fairly typical of those early agencies. I don't know that they felt they needed a redesign particularly, though they knew they were in a bit of trouble. They certainly needed more publicity and a symbolic kind of hype of some kind. And so, you know, what NEA wanted them, after they looked at their collateral archival work, they were shocked, as we were. We saw it, and we couldn't believe it's coming out of the space agency. What had happened, though, is, I mean, you know, the centers were still independent. Yes, they were part of NASA, but they behaved pretty much on their own. They really weren't happy with anything that came out of Washington at that time. And it's funny because to this very day, I know the centers are very competitive, and I get that. I think it's a good thing, probably. But it was everything from funding on, you know, and focus. They all think they're wonderful, and I think they are too. So the net of that is that the work was extremely disparate and messy. It was low standard, and the reason was they didn't have a single graphic designer on staff of any of the centers, maybe JPL, which did exceptional work compared to the other centers. So it's a wild west of graphics, and you know, anything goes. And so I think headquarters kind of got religion early and realized that they had to pull all this together, that they couldn't have 10 or 11 centers looking like, you know, disparate and having their own family style. So our job was really to pull it all together. As I like to say, one NASA, one agency. That was the mission. It went beyond aesthetics. It was really the goal of the whole organization to try to meld them from the old NACA days, you know, into one NASA. And that's a pretty big charge, actually. And it can't be done just with graphics, but it can help. And that's what we were challenged to do.
Now, of course, you started with that work, and you already mentioned some of the values that you wanted in this new logo. Simplicity was one of them. I know. One of the challenges with the meatball itself was there was problems reproducing it and putting it onto things. Having this simpler logo made it a little easier to put on things. Is that right?
That's absolutely true. Of course, the GPO. I can say this now because they did very substandard work at that time. And the meatball didn't help because it was very complicated. It was in multicolors, and you know, it sometimes it reproduced like a thumbprint. You know, it couldn't be done. So, and I should quickly add that I'm told, I don't have personal experience, the GPO does much better work today. Also, the original meatball was a little more complicated than it is today. So it had more going on in it, and it made it even harder to reproduce. So we settled on, it took a month of honing our logotype, making it more contemporary and to anchor the program so it could be used across the board in all mediums. And for part of our presentation was to show it on publications, forms, signing, vehicles, aircraft, shuttle, you know, even exotic spacecraft. And that standards manual, well, actually, the presentation was in fall of '74. Manual came out in 1975. But that was what we were trying to do, was to create something that would last a long, long time and would anchor all this disparate work. It wasn't an easy task, but it was exciting because this is just super agency, which don't get me started. I'm just as excited about it today as I was back then.
Well, this is curious. You talk about the stakes here about this logo, but as I understand it, you presented one solution when you actually designed this. Is that right?
That's true, and that was very controversial. at the time, and everybody would agree that it would be controversial today. In fact, most design firms present multiples. We still kind of adhere to the idea that there is a best solution, and we show that first, and more often than not, the client says yes. But that was very risky. What we did do that was different, wasn't required in our contract at all. We did about 25 demonstrations at great time and expense, showing it, what it would look like on everything, every two-dimensional, every three-dimensional item that I just mentioned, the shining vehicles, aircraft, shuttle, and we played it out against this backdrop to make it a true, what I call Cap-P program. Prior to that, the meatball had been kind of like an ornamental stamp, it was just applied by subcontractors, not just by NASA, of course, to everything that moved, to stick it on. So what we needed was, a family program that would bring it all together and make it work. We even used it as a STEM word. You're probably aware of that, like NASA News or NASA Information. And it really did extend itself beautifully. And this is what happened. That was the difference in the presentation. I think the logo itself was very controversial to the group that we presented to. But when we started trotting out the demonstrations, and you could just see the difference in the receptance in the room, it was just very emotional because it's the first time they'd really seen what it could be, how expansive the program could be, and how cohesive. It was all one agency.
That part of the story really is interesting, the reaction to this. I'm sure you have folks that have been there from the Apollo era that maybe were in love with the meatball and did not want to change. There was a little bit of pushback there, and I know specifically two names that come to mind or that I found. James Fletcher and George Lowe had opinions of their own on just the color scheme and all kinds of things. It was not it was not a universally accepted thing.
No, and the session was certainly among the most interesting I've ever experienced, and the stakes were extremely high. I think that both of them being scientists, as probably today would be the case, they view things through that lens rather than through an art or aesthetic lens. But so there was a lot of controversy. I know Dr. Fletcher, and I say this in all generosity because he's a great guy, and we did wonderful work with him over the years. Just didn't get it, and I know when he saw the mark, and they came back, and Dr. Lowe was talking to him, and he said, "Well, what do you think?" And he said, "Well, I think something's missing here." And Dr. Lowe said, "What is that?" And he said, "Well, there are no cross strokes in the A's." And Dr. Lowe said, "Well, yes. So what's wrong?" He said, "Well, I don't feel we're getting our money's worth." And the fact is that that's one view of it. It was pretty Spartan rendering, and now today you see this copied over and over and over. In my lectures, I do a thing on copycat culture. Thousands of marks are out there that imitate this. But so that was one thing. The other thing was this warm red that we used, which I think Dr. Lowe thought he commented that he thought blue would be more appropriate because space was blue, and then he was corrected by Dr. Lowe saying, "No, space is black." So there were a lot of things that we knew that they'd want blue. In fact, all of our early work was based on that color scheme, that palette. But we thought that warm red was indicative of a real can-do agency, and certainly NASA was that. And but in the end, we prevailed, and they got the logic of it. Here again, sort of an engineering orientation, logic rather than just gut, aesthetics. So it did work, and we got to go ahead to do the program.
Well, wonderful. Tell me about that. Now, I know, you talked about already, you alluded to many elements of how the logotype would actually appear on certain things, and this beautiful thing called a style guide. So tell me about that process.
Well, the programs like this were done in the corporate world, but nothing really in the institutional world, and certainly nothing of this scale or magnitude. So we were adopting things that were very commonplace in the corporate world. And that was to create a document, style manual that would be used by just everybody, all staffers, all the specialists, and certainly inside and out the agency. And NASA was unique in that it had, tons of subcontractors who were very important partners. And they were kind of used to doing whatever they wanted too. So we had to create a manual that was pretty not only well defined, but it was fairly strict in the sense that that we had do's and don'ts, and we're trying to prevent mistakes being made early on by, as I say, both NASA and their contractors. But we also decided that we wanted to do a tutorial, and that's what made it a fairly substantial manual, and a little longer than most at the time. Where we started with some publication design grids and just trotted them out. We found out that without designers, they're going to need some fundamental help. That turned out to be very, very a good decision because the publications improved very quickly. But in this manual, then there are specialty sections on everything that I mentioned, from signing to aircraft to we even did the shuttle in great detail, and some of the spacecraft that were being just developed at the time, and we were able to mark those things and apply it. So it's considered, even at this day, perhaps the most thorough manual and most understandable manual. I did a podcast just last week with a guy. He said, I read the thing frontwards and backwards about 3 times. He was an engineer, and he said, I don't think I've ever found anything so easy to understand. Also with guidance. Now, today, we wouldn't put that much guidance into a manual because our world is more sophisticated. Mm-hmm. But at that time, it was something we needed to do, and it was very, very helpful, I think.
So tell me about some of those elements. You're talking to a guy who unfortunately did not read it forwards and backwards 3 times. So tell me about some of those things. What were these elements that were very helpful to others?
Well, the most extreme might be that we spent almost 2 years, not full time, but working off and on business forms, because we had to work with GPO and like that. So really about structuring with whatever the printing techniques were at those times, typesetting, and detailing it. Not only that, simplifying it. We were able to take the forms across NASA, which were just an enormous grouping, and simplify them into much fewer forms, thereby saving money. And the language, which some people in insurance were simplifying their documents at that time, that's what we did. And so it wasn't really a design issue. It was a detail and engineering issue. And we were able to get those down in much shorter, crisper forms and save a great deal of money on that, which is never talked about much, but I think it's important for government. On the other hand, if you're talking about vehicles, the vehicles on every center were different at that time. So they were able, a lot of them were just saying the name of the center, but there was no connection to the larger entity of the NASA headquarters. So we signed out, we did plans for every type of vehicle, ground vehicle that they had, as well as every aircraft. Sometimes we had to go out and measure the aircraft and really go into that level of detail, so that the entire fleet was had one look. It was really quite beautiful. Of course, the shuttle went through many machinations, and that was a feature in the book. And in the end, the scientists, the people who know how to make it fly, had a huge input, and we were very secondary because we weren't going to get in the way of success.